Hi, hello, namaste. Welcome to JBchem tutorial. If you like my videos, like it. If you want any explanation about topics, please make a comment in the comment section. Today we are going to discuss about Markovnikov rule, and it is also called as a Markovnikov rule. Then what is Markovnikov rule? When a unsymmetrical when a unsymmetrical uh, reagent added to unsymmetrical alkene alkene the negative part of the reagent negative part of the reagent negative part of the reagent attaches to double bonded carbon atom double bonded carbon atom have less number of hydrogen atoms comma the positive part of the reagent attaches to double bonded carbon atom have more number of hydrogen atoms. So we'll see one example. So for example, symmetrical alkene CH2 double bond CH2. So when we make equal parts, it will be divided into equal parts are called as a symmetrical alkene. Unsymmetrical means when we make into equal parts. So when we divide it is not made into equal parts are called as a unsymmetrical alkene. For example, we'll see CH3 CH double bond CH2. So this alkene is known as propene. We will not make it into equal parts. So example for unsymmetrical reagent. So example for it HX. So which will be gives this product CH3 CH2. So this when these double bonds shifted towards this carbon atom. So carbon atom gets negative charge and this CH carbon atom will get positive charge. Negative charge and positive charge. So this we say that one the negative part of the reagent attaches to double bonded carbon atom have less number of hydrogen atoms. So H will be added here and X will be added here. H will be added here and X will be added here. So say that one negative part of the reagent attaches to double bonded carbon atom have less number of hydrogen atoms. Then the positive part of the reagent attaches to double bonded carbon atom have more number of hydrogen atoms is known as Markovnikov rule, either maybe Markovnikov rule. So then what is the mechanism involved in? We'll see. So the mechanism involved in it follows three three steps. Three steps. Number one is the initiation step. Initiation step. Second one is the propagation step. Propagation step. Third one is the termination step. Termination step. So what happened in the initiation? So this hydrogen halide. So the halide group which is an electronegative. So it pulls the electron towards itself, and the H plus ion will be get and X minus will be get. So dissociation of HX will be formed H plus ion and X minus ion. Then this alkene CH3 CH double bond CH2. Then in the presence of the proton, these electrons are shifted towards itself. This which may lead to forms this CH3 and CH positive and CH2, and one more hydrogen will be added. So the carbocation will be formed, and this carbocation is stable carbocation will be formed, and this carbocation, so the carbocation CH3 and CH plus and CH3 in which X minus ion will be attaches this carbocation, and it will be converted into product, that is alkane. And it will be converted into the product. So H ion will be added here, X will be added here, that is one halo, the two halo alkane. 2-halo-alkane will be formed, and 2-halo-propane will be formed. 2-halo-propane will be formed. This is about the Markovnik rule. So then we are going to discuss about anti-Markovnik rule. So Anti-Markovnikov rule. So what it says, when unsymmetrical reagent of hydrogen bromide added to alkene in the presence of peroxide ions. So peroxide, the presence of peroxide, the negative part of the reagent, attaches to. So the negative part of the reagent attaches to more double bonded carbon atom. Double bonded carbon atom have more number of hydrogen atoms. Comma, the positive part of the reagent, attaches to attaches to double bonded carbon atom. Double bonded carbon atom have less number of hydrogen atoms. So this is the anti-Markovnikov rule. So this same hydrogen bromide added in the presence of the peroxide. In the presence of the peroxide, these either may be benzoyl peroxide, either may be hydrogen peroxide. So mostly benzoyl peroxide. The negative part of the reagent attaches to the double bonded carbon atom have more number of hydrogen atom. The positive part of the reagent attaches to the double bonded carbon atom having less number of hydrogen atoms. It is opposite to Markovnikov rule. So we'll see the example. Same example. CH3 CH double bond CH2, that is a propene. So when we added hydrogen bromide in the presence of peroxide ions, either may be peroxide, hydrogen peroxide, either may be benzoyl peroxide, then this CH3 and CH2 and CH2 will be formed. When the bond is shifted towards itself, then this negative part of the reagent, this negative part of the reagent will be added to carbon having more number of hydrogen atoms, and the positive part of the reagent will be added to less number of hydrogen atoms. It will be forms 1 bromo propane. So this is about the anti-Markovnikov rule. Then what happened? We'll see how it will be happen. We'll see in the mechanism. One more thing. This effect is discovered by this Karash and FM Karash MS Karash and FR Mayo in 1933. 1933, in the year of 1933, and hence it is called as Karash effect, and it is also called as a Mayo effect, and it is happened in the presence of the peroxide ion, hence it is a peroxide effect. So this is about, so in the year of 1933, MS Karash and FR Mayo discovered this effect, hence it is called as a Karash effect and Mayo effect, and it happened presence of the peroxide, hence it is called as a peroxide effect. Then we'll see the mechanism. So this mechanism has 3 steps. Number 1 is initiation. Number 2 is propagation. Third one is termination. So in initiation, this peroxide, either may be benzyl peroxide, either organic peroxide, organic peroxide undergo dissociation and forms equal distribution of the electrons and forms 2RO free radical. So this free radical RO free radical which captures this hydrogen atom by free radical reaction and it will be converted into ROH alcohol and Br free radical will be from bromide free radical will be formed. Then this bromide free radical which is reacts with CH double bond CH2. So this free radical which will be this alkene undergo free radical dissociation and this bromide free radical will be attached to carbon atom having more number of hydrogen atoms and it will be converted into CH3 CH2 Br bromide free radical ion will be formed, alkane free radical ion will be formed and this free radical ion, so this CH3 CH and CH2 Br, so which will be bonds to it means here free radical will be formed, so it will be again captures this hydrogen atoms from the HBr. So this dissociation of the Br will be occur and this hydrogen atom will be attached to this ion and it will be converted into this hollow alkane. So CH2 Br will be formed and this hydrogen atom will be attached here and it will be forms this hollow alkane, either maybe one bromo propane will be formed. So in initiation step, dissociation of the peroxide ion will be taken place, which will be gives RO free radicals. So alcohol either may be alkyl oxy free radicals, and this alkyl oxy free radical, which will be captures the hydrogen atom by undergoing dissociation, free radical dissociation, and this bromide free radical will be formed. This bromide free radical which will be attached to the double bonded carbon atom which is having more number of hydrogen, double bonded carbon atom which is having more number of hydrogen atom, and carbon free radical ion will be alkane carbon free radical ion will be formed, and this ion which will be capture the hydrogen from the hydrogen bromide and it will be converted into one bromopropane as a product. So if you like this video, please like it. If you have any doubts regarding this, either maybe any topic, make a comment in comment section. And if you like my teaching and follow my YouTube channel JBchem tutorial to get the notification about my videos and any lectures. You have to follow my YouTube channel JBchem tutorial. Thank you one and all.